welcome back to Kojo's Bizarre Adventure, where I have learned that I can just put my webcam on my laptop. Crazy. I don't know why I haven't done this like ever, because it's like so much. It's actually really straightforward. It means I can just look up instead of like looking this way, you know, and you get a face-on view as well. And I also don't have to worry about my camera just falling down. Genius. Anyway, so just recording a quick video here because I'm currently trying to figure this out. Because I was thinking about named arguments, right? From my language, true, if you don't know. And the way I had it before, if I go ahead and find my true lang, look for functions. Yeah, so the way I had it before was you define a function, just, I mean, if you're not used to this, just ignore the, don't ignore the syntax, but, you know, try to understand that, like, this just doesn't use parentheses, but otherwise it's quite similar to how you would expect it to be. So like we define a var, and then this hashtag is the type. So you have a function literal definition here, like defining an anonymous function or creating one with this, and then these are the arguments here, separated by a semicolon. So they have the type here. The @0, @1 is just for positional arguments. I don't know if I'm going to do that yet, but just that's what that means. And then you have the return type after the arrow here, and then you have the body here. So we're defining well, this is in this case a variable function, but also just ignore that. That just means you can reassign it. Called, actually, it is relevant. It is relevant, and you'll see why in a second. So we're defining a variable function, we're defining a variable identifier, let's say, called f, right? And we are assigning it with type inferred from this function literal, right? So we're creating a function with a, which is the u32, b, which is also u32, returns a u32, and that would be a plus b, right? So it's just adding two numbers, right? Or two u32s. Two unsigned 32-bit integers. And because it's variable, we can reassign it. So we can say that f instead now equals a function of a and b that does a minus b. So here we said that we've defined it as a plus b, and here we're redefining it as a minus b. Hence the variableness, right? The variability of the function. Now, first of all, what is useful? Now, a plus b, a minus b, probably not the most useful. Like, at least, like, you wouldn't create a variable function called, I don't know, add f. Or like, you would, yeah, like, you wouldn't create a function called add and then have it be like this, right? But like, let's say you had a function called print, or like log message, or like gets, I don't know, like let's say you had a log message function, right? And then you want to allow the user on the API side to control the format of how it's logged. So then they could add their own, pass in their own function for how the log works, right? So like that, basically. That would be a good example of where you would want a variable function. There might be some other way to do that, like, well, yeah, I mean, like, there isn't really another way to do that. Like, in C++ right now, I would think of using, like, function pointers. So, like, you pass in a function pointer, then that's your log method. So, one way or another, you do have variable functions. The issue is, it works fine if your function type. So, like, for example, here's a function type here, right? We define, again, f, a literal f, is of type a function that goes from a u32 and a u32, so two arguments, both are u32s, and returns a u32, right? That's the function signature. That's fine. But when we have named arguments, now there's something else, right? Now, with the struct is fine because the identifiers, for all intents and purposes, tend to be part of that struct type, right? Like, if I have a struct with int a, int b, int c, those names, a, b, c, are engraved into the struct. It's why I can't just assign it's why a struct int abc and a struct int xyz are not the same. I mean, even if I gave them the same names, it wouldn't be the same anyway, but my point is, because of how structs cannot equal each other based on content alone, it means that having named struct arguments is not a problem, right? Plus, structs are not mutable. When you create a struct in most languages, including C++ and including Rust, the struct itself is immutable, right? You define it with a struct keyword, and there are no anonymous structs, to my knowledge. Now, Zig, I think, does, but I'm not entirely sure how that works. So let me just check this real quick, because I'm curious what Zig does. But like because there's no anonymous structs, it means you don't have reassignable structs, which means you don't have to worry about like these names changing, right? But with functions, if functions are reassignable, and you know in C++ and Rust they are, because you can have function, function literals. In C++ you have the anonymous functions, and in Rust you also have the anonymous functions, right? Different syntax, but same concept. Closures more so. So then you have an issue, right? If you can reassign the functions, and the identifiers are not part of the function type, so as we had before, right? This like imagine this is a function type, just a U32 and a U32 to a U32, right? There's no identifier. That means that when I go ahead and redefine the function, nothing is stopping me from changing the names. Nothing is stopping me from changing A and B to X and Y, right? And why is that problematic? Because then, if I call the function, right, in a context where I don't know what the fields are, then I can just give them any function name, right? I mean, I can give the arguments any name. Basically, I don't know what the arguments are, right? Like, if I want to require the argument names to be listed, I need to know what the argument names are, or else the compiler can't check have you done it correctly, right? If they're variable, if they can change like on a whim, then my code will just break. Like there's no way for the compiler to check that, to enforce that then, because the compiler doesn't know what the argument names are there. So what you need to do then is bake it into the type. Either into the type or into the identifier it's being assigned to. So I guess there are two ways to go there. And that is not easy. So that's what I'm trying to figure out right now. So first of all, does Zig have anonymous structs or struct literals? Because like it looks like it does, right? Because I think you assign a struct to a variable, but I don't know if you can reassign. Okay, each unique combination of field names and types is its own anonymous struct type. Right. Interesting how that happens. So then two questions. One, can these be reassigned? And two, if two, well, I guess it's just that, right? Like this is actually unnamed. It's interesting. Does that mean if I have point and direction, which have the exact same fields, which have the exact same structure, but different types, can I assign one to the other? So P is an anonymous struct, and then you can assign it another struct if it has the same shape. Yeah, that makes sense. I guess to that end, actually C and C++ do, right? You can define just a struct with no identifier. And then like just have the, I mean like without a type basically. It's like it's anonymous, but you have to assign it to an identifier, right? Yeah. I guess what I'm thinking of, which is different, is an anonymous struct definition. Okay. Right, so this doesn't work. Point direction. They have the same structure, but there's nominal typing. Yeah, so nominal typing is interesting. It means that the identifier becomes part of the type, which is really, really interesting. And a bit confusing, but obviously for good reason. Yeah. So, also, like, you can bypass nominal naming if you just overwrite the memory with the memory that you want, right? I believe you can do that. Let me test this. So let's have, let's not even use Godbolt. Let's just go on my computer here. So let's go into my projects folder, I guess. Into my sandbox. It's empty, nice. And let's create anonymous, I don't know, and nameless, let's say. Right, I have to make it first. Nameless, and then cd into nameless. Okay, nice. So let's go ahead and create our main.cpp. And to kind of demonstrate what I mean, let's include IOStream. That should be all. Our main function. And let's go ahead and have two structs. So we're going to have struct point, which is just an x, int x and y. Well, to make it more explicit, we'll do like this: int x, int y. Okay, and we'll have a struct direction. Okay, so from this, let's go ahead and define our point. So point p equals, and we can use the whatever this is, the aggregation thing, whatever, 1 and 2, right? And we're going to center C out P. Now I can't reflect it for P, unfortunately, so I'll do standard format. I'm using Clang, so I don't have reflection, but even if I did, I'm not sure there is a default thing like that. I'm pretty sure I'd have to do it manually anyway. Yeah, so I'll do X and Y. So p.x and p.y. And I need to include format. So let's include format. It's weird. It doesn't seem to recognize format. I wonder if that's because of the version I'm using. The version I'm using. I don't know. Let's try and compile it anyway. Hilariously, I don't know how to duplicate a tab, so I'm gonna need to go back to it manually. I need to figure that out. Project / sandbox / nameless. And let's go ahead and Clang ++ main.cpp. Yeah, just leave the name, doesn't matter. And then we'll have standard equals +23 should be good. Compiles despite my warnings. /a. Okay, it actually gives it a name. Right, so you have x.1, x is y, and that's right. Now, if I want to do p equals, I mean, first of all, this would work, right? So let's say I do 4 and 3. This should work. Yep. But now if I give it a type, so here I have auto, and I'm going to give it a point here, right? So this should work. Yep. But then if I try to give it a direction, now I'm going to get a error because I'm trying to assign direction to a point. And I get it in my LSP, but just right here for proof, right? No conversion from direction to const point. I don't know why it's const point, but whatever. I guess it inferred that or something. So what can I do here? Well, I can cast a point, I guess, but I don't know if that would even work because there's no conversion. I don't know what it says tmake. Yeah. What I can do though is convert direction to a point pointer, and then dereference that. Taking the address of a literal. Okay, well, yeah, that's an issue, I guess. So then to do that, I would kind of need to assign it to a thing first. So auto d equals, right? Yeah, I think I have to do that. So direction. I guess I don't actually need to strictly do it like this, but whatever. And then we'll take d here. Okay. So now I'm going to compile that. Right, so now I have assigned direction to P using the memory. And the reason this works is because of the memory layout. If I swap these, the order matters. Okay, so let's say I made these instead floats. Okay. Now I expect to have different values. Yeah. So now what I'm doing is these have different types even, but because the layout is the same, like an int x and a float have the same width, right? 32-bit. 4 as a float, if you were to literally take that binary representation and make it an integer, you get, I guess, this 1082 or whatever, and same for y and 3, you get that. So you can bypass this, the nominal whatever, but obviously it's not particularly recommended. Like it's not something that you're supposed to do, and it is also probably undefined behavior because there's no guarantee that, I mean, unless the standard does make this guarantee that the structure is actually like this. I assume the standard doesn't say that yes, int x and int y have to be in this order. Maybe the compiler can change the order of these elements if it wants to. I don't know if it can, but I'm going to assume that that's a thing, in which case it would be undefined behavior as well, because you can't guarantee it as consistent. So, yeah, so it's interesting. So for nominal typing, we only ever do it for structs, it seems. We don't do it for functions, typically, and we don't do it for variables even, right? Like say, imagine I applied this same logic. So let me just undo all these. Suppose I had this same logic here, right? So I have a point and a direction. Now, what if I had just a variable, right? So I had auto, or like, let's say I had a int x equals 5, int y equals 3, right? So now I'm going to say that auto f or foo, whatever, equals x, right? Which is this. Then I want to say that foo equals y, right? This is fine. Despite these having different names, x and y, like they're both integers, so it's fine. X and y. Here, this is not okay because these are treated as different types. Even though that the actual type contents are the same. Like point is an int x and int y, direction is an int x and int y. You know, in the same way that this is an int and this is an int, or rather a 5 and a 3, let's say. So I can do this, but I can't do this, right? It seems a bit strange. Yes, it's useful, but it's strange how it works in this model. It's kind of implicit in a way. Now, it's not, because when you define a struct in C++, like it's pretty clear that yes, it's a struct, you know, not a variable. It's quite different. Like when I go to say point equals, right, a structure like this. Like this is not valid. You can't do it like this either. Can I do this even? No. But in Zig is weird because in Zig you can. In Zig you would define it like, fuck me. Const point equals, so you would have a struct literal. So then you just do const point equals a struct. Right? And now it's like, hold on, these are literally just variables. So like it's kind of like if I had this. I guess C++ isn't the best example because it is quite different, but like in the Zig way, it's like this. This is the comparison you make. Now this wouldn't work. Well, this might work even if constructors work like that, but whatever. Point is, this would be fine to reassign. These would have the same type, but these have different types. And it's just a bit weird that it's like that. Now, I'm aware that struct is like a type keyword. Like, let's say that my language had type instead. Like, then this would be like, okay, like I'm creating two different types. Like these still conceptually have the same type, right? Whereas like in C++, like it's a struct point, not an int point or like it is a type point and a type direction, right? And like this is the body. So like it kind of makes more sense that they're different. Anyway, enough of that yapping. So let me just go out here and remove nameless. Wipe it from the face of the earth. So what do I do in my language? Because I do want to have anonymous structs. I think they're cool. I do want to have anonymous functions. I think they're cool. But I can't have... So like, how does it work? Right, is the question. So like one way I was thinking was like this. So you do have the names of function arguments be part of the type. Which means that any function that has the exact same like names and types for its arguments and also the return type would be compatible and assignable. So that's one way to do it. But it's a bit weird then because it's like the type, like syntactically speaking, how do you do that? Because then like the type of the function is also the function itself, you know? So like we get this strange thing where the literal is the type. The literal is the type. Right? Again, the literal is the type, which is weird. But that's not really true, I guess. Because like, is the function its arguments or is the function its body? Right? So like here, notice how I say equals, right? This is the type of the function, but I'm saying equals this, right? So it's almost as if I had like in my language, well, I'll use Rust for like helping here. It's like if I had let f, my function, right, which is of type, I don't know how Rust does it. Is it fn? I think, which is of type function, let's say string to string, right, equals, but instead of having like this like anonymous function thing, it's literally just x. I mean, not that even. Print line hello. Sorry, but then like the name would be here as well, so it'd be name string inside there, and then it'd be like hello name. Like this would be the equivalent to Rust, okay? Just like to kind of help you conceptualize it. Exact same thing happening here, just different syntax. Also, the function name's different, I guess. Say hello to. Why is it so much longer? I'm worried I'm not breaking it out of the line. Oh, because the return type as well, yeah. Oh, no, wait, yeah, so sorry, so it's actually a void function, anyway. Like, this is what we're dealing with here. And it's like, this is meant to be a function. Not, like, this is a function, but like, then how do I create an anonymous function, right? Question is, how the fuck is an anonymous function then supposed to look? Like, I could have like a separate syntax, I guess. So like maybe I mean, like, it could just be, you know, say hello to, again, function name, which is of type string, right? It's void implicitly. And then say equals, and then have this, right? So we have name, and just print line, hello name, right? Like, this is the Rust way, and this would work. All right, this is Rust syntax. Like, this would work, right? So now we explicitly have a lambda, right? It's just that you have this this kind of redundancy, right? Here. But the name is redundant. So you could infer type. I'll use for clarity there. So now again in Rust, we have let's say hello to function name string. And then, no, not even. So we'll have that, and then just do that, and then we'll have a name type string. I believe this is already valid Rust anyway, minus the colon equals, like that. By the way, like, as I explain this, I'm also figuring it out. I don't know why I'm speaking as if like I have the answer. I am testing it as I go. So like this works, right? So then like you just implicitly infer that the function's type is a function with name of type string, right? Pretty much. Yeah, so then the equivalent in my language would be define, say hello to, of type, like for this one, of type function, name of type string, equals, the small function with name, then the body, print line, hello, name, or at name in my case. Also, it's not print like that, it's just print. So this is the equivalent syntax. Or for short, you would do say hello to hashtag equals for inference, $sign function for the lambda, name hashtag string, that's a type, and the same thing, print hello at name, and then change the syntax to actually be correct. Anyway, yeah, so like same idea there. Huh, I guess that's it then. It's actually pretty simple. I may have overcomplicated it in my head. Because like the type information can be whatever I want it to be, right? Like no one says like a type has to just be, you know, like a set. Like I can put restrictions, like nominal restrictions on my types if I want to. Like it's my type system. Like a type just means, does it fit in the box, right? I can have a set of functions that take a string and return nothing, but also have the strings called with have an argument, called name. Like that is a set as well. So like it could be whatever I want really, or the category. So then I was trying to think of this kind of what implications this has for other things. For instance, what if I really don't care about the name? Or even like with Swift, you have external names and internal names. Maybe I'd have to just go with that. Maybe that'd be the way to go. Like in Swift, Swifts, I believe you have, I might have taken notes on this. Yeah, so like in Swift I'd have, bro, I need to like sort my keybinds because they work, but it's hard for me to get used to use them subconsciously. Like I have Windows O for Obsidian and Windows B for browser and D for Discord, which like works technically, but if I'm just like trying to like do it quickly and like my brain doesn't quite latch onto it. I think the brain works better with like order. So like if I have them like next to each other, it's better. Anyway, func, say hello to, or okay. So for Swift, for instance, you'd have the public name be part of the type, right? So it'd be like say hello to, right? And then it would be function. And we just say that it can be anything. So let's have just, okay, this is wrong syntax. So like, let's say it's, this isn't Swift, but like, let's say Swift did what we were thinking with its own syntax. It'd be something like, actually, this doesn't work at all. Okay, you know, forget Swift. Let's just try the Swift way of doing it. So we could have define say hello to, or yeah, be a function, which takes a string, okay, equals, and then we're gonna have our lambda. So we're gonna have a function, small case because it's a literal here, and we're gonna give it a name. So we're gonna call it name. But then say at name. Okay, let's go with at name for now. Okay, and then that will just print hello at name. Yeah, so the reason it's at, by the way, at is meant to be for like placeholder syntax kind of thing. So like if I just have hello at, this would just take, like this would create a function that literally is this, but like name is just unnamed, you know? Or like if I did at 0 plus at 1, this would create a function that adds two things. So that's what I have here as well. The reason it's at symbol is because it's to signify a hidden name of sorts. So like here when I do at name, the external name is blank, the internal name is name. Okay, that's what I'm going for here. So we'll say this. This takes Swift's approach of having an internal and external name. What the hell? My friend said the more energy you have to do things, the more broke you are because you're young. When you have money to go to £500 concerts, you're an unk. It's a tragedy. It's a good point. Anyway, so notice that here there is no name because the name is implicit. Now say there is a name that needs to be enforced. So here, say hello to is just a function that takes a string. And when we define that function, we create an internal name which is only known by the function, by that specific function body. the public name is nothing, implying that it's a positional argument. So another example of this would be to find add, right? Where we have just a function that, like say, takes a U32, and returns a U32, and that would equal our function here. And now we can, and now we can define our variables. We have like at x, at y, and then we just do x plus y. Or alternatively, with the placeholder syntax, assuming I actually do go on with it, you could do same thing, but then have a literally just 0 plus 1. Yeah. Cool, right? Or let's say we have, now say we have a function that does impose named arguments. So let's say we have what's a good example? We definitely don't need to. It's just easier to kind of reason about it when you have a concrete example that actually makes sense. Like let's say we have create window, which is a function that takes, specifically, we have title of type string, and we have size of type vector, or like a vec2, whatever, right? Like an x and y. And then equals our function. So now to define this function, we have to create a function, and we have to give it named arguments. So we can just do title, right, and size, and then just say that it's whatever. That's not my function sometimes. Like this, right, like that. Or alternatively, you could have internal names. So you still have to say title, but for an internal name, you can say at t, for instance, and then you could have size just be at s, right? So it's like something with title and size, something with t and s, right? Like that's the difference there. And in both of these cases, when you call the function, it'd be the same. So you'd have just create window with title equals my window, and size equals I don't know, like a vec2 with x equals 800 and y equals 600, let's say. Okay. Here though, you'd have implicit arguments. So no named arguments. Function call uses positional args. So we just have add 5 and 3, for instance. And boom, pretty straightforward. So it means that the type is encoded in the function signature, which we have here. And that is basically it. I mean, fairly straightforward, right? So I wonder if this is what Swift does. But it's quite handy, isn't it? It means that you cannot just assign like a random function that that just happens to have a string and a vec2. I'm trying to think like if there are any instances where you'd want to bypass that. Probably not though. Or like, what if I want to have a function that, well, the thing is, I can't have a function that just accepts any name, right? Because then I can't call it. So there, like, I'd have to rely on positional args. Yeah, that's fine. So like, if I want to have a function that like just accepts any name, then you would go for this approach of just using nameless things, and then they would have to define their own internal names. That's fine, right? But it's like, say like you have an API that wants to accept just like, I don't know, some generic function that can have a different interface. But then it's like how that, yeah, like you can't call that a function. Like you'd have to explicitly wrap that function in another function to then remove it, type thing. Like if you wanted to take a function and remove and erase its nominal info, type info, you could do this. So you have a function that has an internal title and size, which means it's just two type parameters, which equals like two nameless type parameters, two nameless arguments, and then just say this will call create window with title equals title and size equals size. I don't know if it's worth adding sugar for this, because I don't know how this would be used, how this would be useful. Like the named argument discarding. So for structs, we'll probably just work the same. Well, I don't know about structs yet. I wouldn't worry about that yet. Okay, so then what do Swift function types look like? Considering they use named, considering Swift functions used named arguments. Closures never have argument labels. Labels are only a feature of named function declarations. Oh, so that's actually different. That's interesting. So like Swift might be the first language in history, or at least one of the very few, to fucking doxing me. What the hell? One of the few languages to actually have a difference between closures or like anonymous functions in general and function declarations. Like func declarations are actually different from these anonymous ones because these can enforce their name parameters. That's very interesting. Also, yeah, default values. Like, would default values be part of the type? They don't need to, right? Yeah, no. I assume so. Because, like, if I have... Ooh, do they need to be? If I have a function... Notification. If I have a function... gets reassigned. If I reassign a function and it goes from default parameter to no default parameter, then the compiler, I guess default arguments would actually have to be part of the function signature, right? Or like at least whether or not it has a default argument has to be part of the function signature. Interesting. For multiple return values, you have to use tuples and tuple labels like quotient. Okay. That's weird. So this is really tricky. Another issue is default arguments. It doesn't even less so. I don't think the function. I think the values themselves need to be part of the type, but whether or not it is given a default has to be, or else the compiler can't deduce whether a function call will run or not. Yeah. So that's interesting. Okay. Well, I need to go now anyway, but yeah, just a bit of thought about that. Because I want to have a system that actually that is consistent. I do want you to be able to have anonymous functions and assign those to identifiers, and those are your functions, right? Rather than having these two different constructs of like a function and a function, like what? Or like a closure makes more sense, being a separate thing, but like even then, an anonymous function is not a closure. Yeah, closures are actually quite an issue as well, because like if they do close around something, you can't necessarily reassign them. So that's a problem too. I don't know. Many questions. But like the one thing that is absolutely certain is that anonymous functions should be in the language, or closures, whatever, because they are extremely important. So, like useful rather. So yeah. Like either way, like even if you don't have anonymous functions, you can still probably pass in functions anyway, or like a pointer to a function and call it. So like there are ways to get around it. So all you're doing with an anonymous function syntax is just making it more convenient. So the question is how to make it convenient, with like the sugar of that, while still making it make sense. And that is having function literals in the same way you have value literals like numbers and whatnot, and string literals. And then I'll also see how this applies to type literals, trait literals. I don't know. We'll look into that and see what happens. But yeah, very interesting.